Why are Cartesian x and y coordinates so essential? Well, they enable us to analyze and solve problems systematically across various fields, from physics and engineering to computer graphics. The Cartesian Coordinate System provides a universal language for describing the position of objects, and it set the stage for numerous scientific innovations, including cartography and computer animation. Mathematically, it's even set the stage for geometry and calculus. So let's learn to use this important coordinate system. Welcome back to Rosie's STEM. Today we're uncovering the mysteries behind terms like abscissa and ordinate in the Cartesian Coordinate Plane. The Cartesian Coordinate System, as we know it today, owes its existence to the brilliant mind of René Descartes, a 17th century French philosopher, scientist, and mathematician. Descartes revolutionized the way we understand geometry by introducing the concept of using numerical coordinates to represent points and shapes on a plane. The legend says that Descartes was lying in his bed watching a fly on the ceiling when he got the idea of describing where the fly was using the edges of his ceiling. This groundbreaking idea laid the foundation for modern analytical geometry and opened the door for countless mathematical discoveries. So let's talk more about the coordinate system itself. This is a Cartesian plane. Coordinates on this plane are given as an ordered pair of x and y values, like you see here on the right. The abscissa, or the x-coordinate, signifies the horizontal position of a point. So that would be moving anywhere here on this x-axis. Think of it as the left-right guide on a mathematical map. The ordinate, or the y-coordinate, represents the vertical position, so that guides us up and down along the y-axis. Together, these coordinates create an intricate grid that allows us to pinpoint any location on this plane. So think of it like a game of battleship. With just two directions, horizontal and vertical, you can communicate positions to a partner. To plot a point in this system, you start at the origin, which is right here, typically denoted as 0, 0 because it's 0 horizontally and 0 vertically. And this is the point where both our x, or horizontal, and our y, or vertical, axes meet. We move horizontally along the x-axis based on the abscissa value, and then vertically along the y-axis based on the ordinate value. Positive values indicate moving up for y or right for x. Negative values indicate moving down for y or left for x. So let's do a couple of examples here. First, the point 2, 3 has 2 as an abscissa and 3 as an ordinate. I would move to the right 2 on the x-axis and then up 3 on the y-axis to plot my point. Negative 5, 6, I would move to the left 5 on my x-axis and then up 6 on my y-axis and then plot my point. And then finally, negative 2, negative 4 would be to the left 2 and down 4, and then I would plot my blue point. By connecting these points, we unlock the power to create intricate shapes like this triangle, lines, and curves that are going to represent an array of real-world scenarios. Another term that you might hear when talking about the coordinate plane is the term quadrants. Quadrants are the 4 squares that are made by our x and y axes. You can see here it splits my plane into 4 pieces. We number these coordinates and use them to talk about positions of points or shapes on the plane, and we can use them to kind of tell people where to look in relation to the axes on the plane. So this top right portion we call quadrant 1, then to the left of that is quadrant 2, below that is quadrant 3, and to the right of that is quadrant 4. For example, I could tell someone to look at the part of a curve that lies in quadrant 4 and talk about its positive x and negative y values.
It's incredible to think that this method, born from the collaboration between math and philosophy, continues to shape our understanding of the universe. Descartes, who is perhaps best known for his quote, "I think, therefore I am," might not have been the person you would expect to influence entire fields of math, but he's one of the many examples of mathematicians who also had interests in philosophy, art, and other sciences. He even studied law. He's proof that math does not need to be left only to math professors. We all benefit from multiple perspectives. What are your reasons for learning more about math? Tell me in the comments below. Whether you're a student, a math enthusiast, or someone who's just curious about the wonders of the world, understanding the Cartesian system not only enhances your mathematical skills, but it connects you to a legacy of innovation and discovery. I hope you enjoyed unraveling the mysteries of the Cartesian coordinate system with me. If so, don't forget to share your thoughts in the comments down below and subscribe to Rosie's STEM for more exciting STEM content. And until next time, stay curious.